Hello, hello, hello. Are you ready for what's gonna come? Look at the background. It's kind of creepy. It's kind of weird. Maybe. I don't know. 8.4, part 2, multiplying rational expressions. So we're going to have fractions. We're going to multiply them with variables. All right, students will learn how to multiply rational expressions. Make sure you have your notebook, pen, pencil, calculator. You're probably going to want your decimals tab out, ready to go. And let's get into it. This is just a pre-example. Just watch, don't copy. Factor each side. So you want to look at 4x squared minus a 16. What you want to pay attention to is the GCF, the greatest common factor. You want to think about this as 4 times 1 times x times x. And then the 16, you want to think of it as 4 times 4 times x. All right, what do both terms have in common? Both terms have a 4 and an x. Therefore, I could pull out a 4x. Whatever I did not circle makes it back into our parentheses. Okay. All right. This one's a little different. This term over here where the 16's at does not have an x. So here you could only factor out a 4. And now we're going to have x squared minus 4. This right here we've talked about in the past. You should recognize this as differences of two perfect squares. So make sure that 4 is still out. And when we have it as differences of two perfect squares, it'll be x plus 2 times x minus 2. Let's move on. Pencils down still. All right. Let's think about when we multiply fractions. We need to multiply straight across. Here's a baby example from the 3rd grade. Remember that? A couple ways you could have done it. You could multiply straight across, or you could cross cancel if you know how to do that. When you multiply straight across, you get 18 over 10. But wait, do not forget to reduce. So you can see that the 18 and the 10 each are divisible by 2. Therefore, we're left with 9 over 5. All right, here we go. Let's go ahead and work on this one. We can multiply straight across, and then we could simplify. It is up to you. All right, here we go. So 4 times 2, that'll give me the 8. And then here, what we do here is we're going to add the exponent. So 2 plus 1 would give me a 3. In the bottom, we're going to have 12 times 20. So 12 times 20 would give me 240 on the bottom. And then this is q to the 1, that's q to the 1. Again, since we're multiplying, you add the exponent, so that's going to be q squared. Couple things we could do here. You're able to simplify the 8 and the 240. Let's see if maybe a 4 goes into 240. Oh, it does. Let's see if an 8 goes into 240. Beautiful. Each one's divisible by 8. So I'm only working with the coefficients with the numbers in front. So 8 goes into itself 1 time. 8 goes into 240. According to my crustiest calculator, it says 30. And then we have q to the 3rd power over q to the 2nd power. Fractions, that's division. Okay. I know a couple months ago, probably back in December, we went over properties of exponents. So here you have division. So what you need to remember, because we have the same base being the q's, you're going to subtract the exponent. So top minus bottom. So it would look like this. Q to the 3rd minus 2. Top exponent minus bottom. All right, so top minus bottom. All right, so here we should have q to the 1. And since the bigger number was on top, so the q to the 1 has to stay on top. So this would be 1 over 30q. Make sure that q stays on top. Another way you could have done it, this is my answer. Another way you could have done it, yes, you could have expanded. You can do that. It's up to you. But at a certain point, you're going to have too many, right? So those would have canceled, and that's where you would have seen just the q. All right, let's try another one, guys. Okay, so now we have 3g minus 4 over g plus 5. And then we have 2g plus 10 over 2. When you have something like this, you want to try to see if you're able to factor out anything, okay? If you're able to, do it. And then once you're done factoring, you want to see if you could simplify or you could cross cancel or something of that effect. On top here, I can't do anything. On the bottom here, I can't do anything. If I see here, I can break this down. This is 2 times g. And then what gives me 10? 2 times 5. If I look at both terms, what do we have in common? We have a beautiful 2. So a 2 gets to come out and play. All right. Now you want to see what you're able to cancel out. You could cancel out stuff up and down or across. Okay. I see a g plus 5. That will cancel out with that. I see a 2. That can be canceled out as well. So I'm left with 3g minus 4. Okay, I am done with this one. It could be 3g minus 4 over 1, but it's the same thing. Let's try another one. Pause it, of course, and copy it down. Again, you want to check to see if you're able to factor anything out. I'm looking at the first fraction and the numerator. I can't do anything here. If I look at the denominator here, I could see I could probably factor out some stuff. So this is 2v times v, and that would be 1 times v. Would you agree? I'd say so. So we have a v in common. If I look here on top of the second fraction in the numerator, you should be able to recognize this as differences of 2 perfect squares. Why? That's v and v. What gives me 81, 9, and 9. If you don't believe me, check it on your calculator. And so this is going to become v minus 9 times v plus 9. Okay? So then it'll look like this. Once more, you want to check to see if you can cancel anything top and bottom or across. I see a 2v plus 1 that could go away, and I see a v minus 9 that can go away. Let's see, what do we have on top? In our numerator, we're going to have v plus 9, and then over v in the denominator. I'm technically done here. I need to check for a restriction, though. So restriction. Remember back in the day when they told us we couldn't have zeros on the bottom? Yeah. Whenever you have a variable in the denominator, you should be checking for a restriction. So v could be any number except for 0. You'll see another one right now. Copy that down, please. Copy this one down, and let's go ahead and start factoring this bad boy. All right, let's go. We have a trinomial here. Remember A, B, C. Remember that junk? All right. And on top, it's A times C. Bring down the B. Remember that? So remember, you have a 1 here, and 1 times a negative 4 is a negative 4. And my B value is a negative 3. So we need numbers that'll multiply to 4 and add or subtract to the 3. So I'm going to go with 4 and 1. Be careful with your sides because it needs to subtract to that negative 3. So the 4 has to be negative and the 1 needs to be positive. Can we factor anything else out over here? Yeah, we can. 2 times g. Hold on. Let me quickly go back. So this will factor out to g minus 4 times g plus 1. And then I'm going to put everything together. You'll see. And this is 2 times 5, right? Again, what do we have in common? That 2. So a 2 gets to come out and play. And we have g plus 5. You'll see that in the fraction right now. Let's check the second fraction. G plus 5, nothing could happen there. Over here, yeah, it looks like I could factor out some stuff here. It looks like we have a 2 and a g. in common, and so a 2g gets to come out and play, it looks like. And then inside my parentheses will be everything else that I did not circle. So everything in factored form will look like this. At this point, you want to check to see if you're able to cancel out anything, top and bottom or across, right? So you should see a couple things go away. Bye. Bye. And let's see, on top it looks like I'm going to have a g plus 1. In the bottom I have this 2 hanging out and this 2g. It says multiplication, so 2 times 2 would give me the 4g. Again, I need to see what values g cannot be. We're not allowed to have a 0 down there. So we're going to set the denominator for the restriction. Restriction not equal to 0. So it's going to be 4g cannot be 0. Essentially what we're doing is we're solving for the variable. Divide by 4, divide by 4. So g could be any number except for 0. If it's 0 on the bottom, our whole world is going to collapse and fall. And what am I going to do now? There's no more Lopez Landia, guys. All right, let's continue. All right, let's see if we can factor this again. On the bottom, we should see differences of 2 perfect squares. This is going to be v plus 4 times v minus 4. On top, remember A, B, C again. And we can do our magic X, A times C, bring down the B. So I should have a positive 10 there and a 24. Thinking of numbers that are multiplied in 24. I know 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. Okay, which of those pairs will add up to the 10? There they go. And they're both going to be positive. There we go. So factored form should look like this. V plus 6 times V plus 4 plus 4. All right, let me put everything back together. Boom. Make sure you have that written down too. Once more, you're going to check to see if you have anything that's the same top and bottom. I'm seeing a couple things right now. Bye. Right? That could go away too. And let's see what we have left. It looks like we have V plus 6 on top over V minus 1. Same thing. This is my answer, but I need to find the restriction. All right. So set the denominator not equal to 0. Add 1. Add 1. V cannot be a positive 1. If V is a positive 1 down here, let's see, substitute it in. What's positive 1 minus 1? That would make it a 0 at the bottom. And that's what we do not want. Because again, then the land of Lopez will fall apart. And we don't want that. All right, guys. We will see you soon. Bye.